Hi, I'm Vince. I'm with Team Hope This Works, and I'll be walking you through some of the design elements of the BUBO Eco. The BUBO Eco is a bathroom utility bot that specializes in allowing users to reduce water waste, excess water waste, while performing personal hygienic tasks. The design of the BUBO Eco is compact and affixed to the front of a faucet that uses a lever type faucet opening. The slim silhouette minimizes safety risks and is further supported by the rounded edges of the housing units and utilizes this trunk-like structure to affix the bubo securely to the base of the sink. These arms um, are what allows the bubo to perform its tasks in reducing water waste. So these arms affix around to the lever of the faucet. And as the faucet is turned into the on position, the arms will articulate with it and allow full articulation of the faucet to turn on and off, as well as hot to cold. When the arms are moved upwards, when the faucet is turned on, um, a, a switch, mechanical switch within the housing will trigger and is operating as a sensor, even though it's a mechanical switch. After the switch triggers, it will start a timer, and after the timer elapses, the motors within the housing will begin to draw the faucet lever down into the off position. Um, Now we'll take a deeper look at the BUBO Eco to see the components that are powering this unit. Um, we've assembled a circuit consisting of an Arduino Uno, a breadboard. We have our mechanical switch here to the right, an L293D, and two DC motors. So this switch here, again, this is our mechanical switch that is operating as a sensor. Um, these orange wires are showing its connections and it's feeding into the Arduino pin 2. We're using a resistor here to minimize any false reads that go into this switch. These yellow wires go into our first DC motor. They connect to our L293D uh, all the way down to our Arduino Uno in pins 3 and 4. And our second motor is also connected to the L293D and into pins 5 and 6. In the code, we define our constraints to map to our pin assignments for the switch and motors. We're also implementing a state tracking variable of if or else, to control when the motors should activate, ensuring that the robot only performs the faucet shutoff task once per switch activation. Um, our live logic checks sensor inputs and controls motor outputs accordingly, and it matches the physical wiring within our simulation. So the way that this system is working, once the faucet lever is actuated into the on position, this switch will be triggered by the physical interaction and will switch into the on position. There is a 9-second delay that will allow the user to wash their hands or perform their hygienic tasks. And after 9 seconds, those motors will start to actuate and bring that lever down into the off position. One last function to cover is how this BUBO Eco will connect with other BUBO robots to coordinate the bathroom cleaning process or bathroom tidying process. So after the BUBO has ran through all of its functions, a short delay, right now we have it at 3 seconds, but potentially longer up to 30 seconds. After that delay, the BUBO Eco will send out a command to initiate the BUBO Splash to begin cleaning activities around the faucet, around the sink. We can see here that as the motors turn on, it performs its function, turns off the faucet, and then sends out a command to begin cleaning around the sink using the BUBO Splash.